Okay, this is Webwork homework 1.1, chapter 1, section 1. First problem, it says the equation has two solutions and it wants the distance between those two solutions. So, to solve an absolute value equation, you want to take what's inside and set it equal to positive 32, and then take what's inside and set it equal to negative 32. Because there's going to be two solutions, right? An absolute value looks like this, and there's going to be two solutions. Okay, so subtract 32 from both sides, you get 8x equals 0. Subtract 32 from both sides, and this one you get 8x equals negative 64. Divide both sides by 8. In this case, the solution is x equals 0. And in this one, it's x equals negative 8. So the distance between those solutions should be 8 for me. All right, the next problem then says I want you to solve this. Now, keep in mind, this is, I'm going to rewrite this as x minus 7 over x minus 1. I'll just do square root. That's the same thing, right? The negative brings it to the bottom as positive, and then the 1/2 power is really the square root. And then I still have plus 3 square root of x minus 1 equals 0. Now, since I have a fraction here and an equal sign, I can clear fractions. We're going to do that all year long. To clear fractions, you multiply through by the least common denominator, which in this case is x minus square root of x minus 1. That cancels. If I multiply this by the square root of x minus 1, that's just x minus 1 squared, right here. And if you square a square root, it undoes that. So I end up with x minus 7 plus 3 times x minus 1. Don't forget to put that in parentheses, though. I do have to distribute that 3. So now I'm just solving this linear equation, which is x minus 7 plus 3x minus 3 equals 0. That's 4x. If I add like terms, minus 10 equals 0. So I have 4x equals 10, x equals 10 over 4, or 5/2. Next question is a question you might remember from geometry. Let's do some algebraic modeling to set up this. It says that 142 centimeter tall person casts a shadow that's 136 centimeters long. So I'm going to set up a triangle there. It's supposed to be a person casting a shadow. At the same time, the building casts a shadow that is 162 meters long. The question is, how tall is the building? I'm going to put these in the same units. So this is centimeters. I'm going to do 1.36 meters. This would be 1.42 meters. So let's set up a proportion then. That's our algebraic modeling. We can do height of the person divided by height of the building. It has to equal length of the shadow of the person divided by length of the shadow of the building. If you cross multiply and solve this, you get x about 169.15. Okay, the next problem says the stopping distance d of an automobile is directly proportional to the square of the speed v. That's our relationship. Now, we can make it exactly equal to if we have the right constant in front. So we need to find what that constant is, which then, narrows down the exact relationship between the square of the speed and the distance it requires to stop. It gives us a point though, a VD ordered pair. It gives it takes 80 feet to stop when the speed is 40 miles an hour. So we can plug 40 in for V and 80 in for D, and we can solve for K. If we do that, we get K equals 0.05. So our equation then is distance equals 0.05 times the speed squared. That's the relationship, 0.05 times the speed squared. And then if we plug in 50 miles per hour for V right here, and just do 50 squared times 0.05, that gives us 125. So if we're going 50 miles an hour, it's going to take us about 125 feet to stop. Okay, next one, we're just solving an equation again. It wants us to give the 3 answers. So to solve this, I'm going to try factoring. So I'm going to pull out an x squared, in which case I have 5x squared minus 3x minus 1 is equal to 0. And then I'm going to try to factor this if I can. 5x and 1x. And let's do minus 1 plus 1. And that doesn't work, so it doesn't look like this factors, so I'm going to try to use the quadratic formula. Quadratic formula is the opposite of b, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. All right, double negatives cancel. This is 29, so it's 3 plus or minus the square root of 29 over 10. Which, there's three answers then. Obviously, the first answer is 0, x equals 0. And then if you do if I do 3 plus square root of 29 over 10, that gives me x equals one of the I guess the biggest number, which isn't very big, but 0.8385. And then the smallest number is if I do 3 minus the square root of 29 over 10, which gives me negative 0.2385. Now, Webwork can be picky about the decimals, so if you are going to enter in decimal answers, do it to like 3 or 4 decimal places. So check that to make sure that that works for your problem. You might be able to enter this in as a fraction, I'm not sure, but that's obviously more difficult than entering in 4 decimal places. Okay, let's try to solve another equation. This is a different one, it's got a radical in it. So let's move the 5 over to the other side by adding 5 to both sides. Then let's square both sides. That gives me negative 2x plus 4 equals, and then if I FOIL this, we've got 9x squared plus 15x and 15x would be 30x plus 25. Looks like we got a quadratic, so I'm going to add 2x to both sides, make this 32. And then I'm going to subtract 4 from both sides, making this 21. And you could try to factor that. I'm just going to go right to the quadratic formula and do opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I'll get those two decimal solutions and then try to plug those in. Alright, I get these two answers right here. Left it to 4 decimal places. I enter those in, and it also asks if they're actually solutions, because a lot of times when you're dealing with square roots and an equal sign, you can get what's called extraneous solutions, where you solve an equation and a solution pops out algebraically that's not actually a solution. So algebra is not a perfect language. So it turns out that if you check both of these, this one does not work for me, and this one does work. So you got to check both of yours. I know it's a pain. I know it's hard to do with all these decimals, but check them to make sure that they both work. Next problem, you're solving an absolute value. I know it's in the denominator, but just cross multiply or clear fractions by multiplying by the least common denominator. Whatever you want, you get this, right? You're going to multiply this to both sides. And now you want to take what's inside of the absolute value, set it equal to 1. Take what's inside of the absolute value, set it equal to negative 1. And you're solving both of those equations. So subtract 2 from both sides. You get negative 9x equals negative 1, so x equals 1 over 9. Subtract 2 from both sides, you get negative 9x equals negative 3, so x equals 1/3. Those are our two solutions, and it wants us to separate them with commas. Okay, the next problem says NASA launches a rocket at t equals 0 seconds. Its height in meters above sea level is a function of time given by this equation. Assuming the rocket will splash down into the ocean, what time does this occur? This is a parabola that opens downward, so the height, this is time, this is height. When it reaches the ocean at sea level, it's going to splash into the ocean. That's the time. We're looking for that 0 right there. So to find it, we can use the quadratic formula and pick the positive solution, not the negative one. I guess that's probably the easiest. You could also graph in your calculator, plug this in, change your window and do second calculate 0 to find that. It's another easy way. My calculator's frozen, otherwise I'd do it for you. We can do that in class. But I'm going to do the quadratic formula, opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. I'm going to pick the positive answer, so I'm going to pause it, evaluate this. And I got 63.07 was the positive solution. Enter that in. Make sure you have enough decimal places, because Webwork's picky about that. Now we want to find the maximum height. If you remember, the x-coordinate for the vertex is negative b over 2a. So if you solve that, in this case you get negative 307 over 2 times negative 4.9, which gives you a positive value of about 31.3 seconds. Now, that's the x-coordinate for the vertex, so that's the x-coordinate up here. That's how much time goes by before it reaches maximum height. To find its maximum height, we have to plug that x value into this, or that t value, into this equation to get our height. So you have to go ahead and sub this in for t. I know it takes a little work, but then you will get the right height. For my height, I got about 4,937.62. And that's in meters. Okay, and I hope this helps.